starting with the name of Allah Almighty, the most gracious and the most merciful. This is research paper ID 206. The title for this research is A Premature Detection of Melanoma using CNN, and this is submitted to the International Conference on Green Computing and Engineering Technologies 2020. The following are the names of the authors, which includes Salar Khan, Sadan Shahid, Mir Shehroz Ali, Syed Mohsin Raza Zaidi, and Zansar Faraz. And we are going to be representing Sir Syed University of Engineering and Technology, Karachi. This slide consists of the table of contents. The contents initially includes the abstract and research outline. Then comes what is melanoma, its types, the prevention from melanoma. Then comes over the role of CNN algorithm, which is also known as the convolutional neural networks algorithm, and image classification, alongside melanoma and deep learning, training and validation, and conclusion. So without further ado, let's move towards the abstract. What we know is that melanoma is the deadliest form of skin cancer. It is a type of cancer that develops from the pigment containing cells known as melanocytes mutate and becomes cancerous. Even in such a modern cultured society of today, it is a very difficult task to detect such a disease, and there are quite a few applications or systems developed for these tasks which provide services only through paid subscriptions. We intend to develop an application that detects melanoma without any subscriptions. Melanoma is a hazardous type of skin cancer that is usually curable if and only detected early, as the biopsy or the diagnosis of the disease is a bit expensive and time-consuming procedure. Therefore, to tackle this issue, we will be developing an Android application through which we can detect melanoma through the image processing techniques with the assistance of the convolutional neural networks algorithm, with a training accuracy of 98% and testing accuracy of 94%. Moving towards the research outline, what we have acknowledged is this: in the prior days, individuals who were diagnosed to have melanoma would not realize that they have been polluted. They would simply envision if the mole on their skin is only an ordinary mole or bacterial allergy, and there is no compelling reason to oblige vigorously costly tests or treatments. In this specific research, we provide benefits to the clientele to click a photo of the mole, and the application will show the outcomes if the client is determined to have a melanoma or not. The task would defeat the issue of costly determination tests that are selected in the conclusion of melanoma. It is the principal goal of this application to identify melanoma with least measure of fortune to be actually practically spent. These possible tasks will be performed using machine learning. In the vast portfolio of science, a very popular and efficient field occurs which is normally known as the machine learning. Machine learning is included in data mining, which basically focuses towards the inference of models that require prior well-known data into the relation with automation. A machine learning model can become familiar with the examples of medicinal detections of tremendous quantities of patients. This technique can assist doctors with foreseeing future occasions at a specialist level, drawing from data well past the individual doctor's training experience.
What is melanoma? Melanoma is one of the major types of skin cancer, considered as the most aggressive disease as compared to other. However, this cancer account possibility of only 4%, but it may cause serious illness or death if not detected early. Melanoma, also called malignant melanoma, a kind of malignant growth. It develops from melanocyte, a pigment-producing cell. It mainly appears on the skin but very rarely in the mouth, eyes, or intestine. Melanoma have basically four types. The number one is superficial spreading melanoma. Superficial spreading melanoma is one of the most frequent kind of melanoma. Around 70% of cases of melanoma belong to this type. The second one is nodular melanoma. It can be found as the secondary most frequently detected type of melanoma, and it includes around 15 to 20% cases. The third one is lentigo maligna melanoma. This type of melanoma most often develop in older people. The ratio of this type of melanoma is about 15 to 20%. Finally, the acrolentigenous melanoma. This kind of melanoma usually occur on those people who have dark skin, like Asian and African. The proportion of this type is about 5% of all the melanoma and other kind of skin cancer. Prevention of melanoma. Keep away from the sun during the mid of the day. Wear protective clothes. Abstain from tanning light and baths. Become familiar with your skin so you will see changes.
So, manual recognition of melanoma is a dreary, time consuming, and well on the way to involve human blunder, as most areas of the cells are the part of unpredictable, irregular, and discretionary visual points. It has been shown in the past that machine learning algorithms perform better than a human pathologist and dermatologist. Medical image processing using machine learning provides more accurate results as compared to the objective diagnosis given by a pathologist or dermatologist. Now, when it comes to image classification, CNN becomes a priority because of its high efficiency. Now, in our research, the implementation of the CNN model produces an overall of both training and testing accuracy of above 90%, which is quite superior and more efficient than classical image processing techniques such as clustering and entropy-based techniques, while improving the results of existing CNN used for segmentation in non-medical contexts. Computer vision can be significant in medical image diagnosis and can be established through many existing frameworks. The contribution to the framework is the mole image and afterward by applying image processing strategies through which it examines to finish up about the proximity of melanoma. The mole image analysis tool validates all the melanoma parameters by following its ABCDE rule, where A stands for asymmetry, B stands for border, C for color, D for diameter, and E for its evolution. Now, the extracted feature parameter are used to classify the image that whether the captured image of a mole is a melanoma or not.
Okay, so first I will talk about the dataset which we have gathered from Kaggle. It consists of two classes, namely melanoma and non-melanoma. We have used a deep learning algorithm called convolutional neural network, in short CNN. This algorithm is used for image classification and it is the most effective algorithm for image classification. The process of applying a deep learning algorithm includes three major steps. Number one is data preprocessing. In data preprocessing, we make the data set in its proper condition when we pass it into the training phase. It will be done by applying two major steps. Number one is data separation and augmentation, and number two is normalization. The second step of applying deep learning algorithm is building the model. The second step is to build a model, and without having any kind of model, we have nothing to train on it and generate the result. To build a model, either we could build it from scratch or use a pre-trained model. In our project, we have used a pre-trained model called ResNet. The third and final step is training and evaluation. Just like in this project, after applying to pre-processing and building the model, we will then pass the dataset into the model and adding required parameters such as the number of epochs, steps per epochs, validation steps, and validation data. During the training, the model will be looking into the images for features, which we call it as feature extraction or feature engineering. After the training part, the next and final step is the evaluation step, in which we determine the performance of the model, that how well the model perform in the training part and in the testing part. To improve the training and testing accuracy of the model, we will use an optimizer called ADAM. Okay, so this is our research model, in which we have defined the flow of our model and like how we have created our machine learning model. So first of all, we gathered our dataset from Kaggle. Then we implemented a pre-trained model called ResNet. Then we added two dense layer, and then we have phased it and freeze it. And after that, we compile Adam and binary Gaussian trophy, and then we have applied data augmentation. And in the final phase, we have done training and evaluation. Okay, so below are the graph we have provided, which show us the variation and accuracy, which show us variation in the accuracy and loss for both training and validation. Okay, moving on. First one is training accuracy. Okay, one thing is to remember that we have taken x-axis as number of epochs in each graph. So in this first graph and training accuracy, we have x-axis as number of epochs and y-axis as training accuracy. The first point is 1, 94.31, which means that at first epoch the training accuracy is 94.31%. The second point is 2, 96.9, which means that second epoch the accuracy is 96.9%. We are using total 5 epochs in our model, so it will stop when the fifth epoch is completed. The second graph is training loss. Here our x-axis is also same, the number of epochs, and y-axis is training loss. I have already explained how we have done the plotting, so I don't think I need to explain it again. And here also it will stop at when the fifth epoch is completed. But one thing I will tell that by training loss, it means that the training loss shows how much bad the model prediction is. The lower the bad prediction, the greater the performance of the model will be. The third graph is validation accuracy. Here also x-axis is same and y-axis is changed. It is validation accuracy. The plotting is done in the same way as the previous graph, and it will also stop when the fifth epoch is completed. Moving on, the final graph is validation loss. Here it is here the loss shows how much bad the model prediction is. The lower the bad prediction, the greater the performance of the model will be. Same as the case of training loss.
In conclusion of this presentation, we know that melanoma is such a disease which needs to be diagnosed as early as it is possible in order to treat or cure it, and this innovation will not only help in diagnosing the disease, but it will help being a cheap and easy solution to this issue. The diagnostic tests for melanoma are either so expensive or are not easily accessible for everyone, but this application will solve all these problems. This application will definitely help in declining the ratio of deaths due to melanoma. Machine learning is utilized for making this research possible as it improves with experience. The more we use it, the better it will become and will help in early detection of melanoma using its algorithms. If we look at this innovation 5 years from now, we believe that it would really help the people, the audience who are in the actual need of a solution to get rid of melanoma, and will this research decline the spreading of this disease due to the lack of early diagnosis. Thank you very much.